Hi, I'm Reese Hill, the developer behind the FMV software. So today I'm going to look at a very brief history of the development of the FMV, or the FRAM Model Visualiser, and then we'll look at the functionality of the latest version, the 3.0, that's now available as a web-based application for all operating systems. A couple of years after Professor Hollnagel published his updated FRAM method, we were in discussions about a software tool that could help visualize the building of a FRAM model. And his intention right at the very beginning was to have a basic software tool that was open source and to be able to build extensions on top of that, such as simulation packages, running instantiations, calculations of variability, or some other type of dynamic simulation. So at the time, there was an existing software, the FRAM Model Builder, which helped construct a FRAM model and produced a data file that was in a XML format. So we took that format, and that was the basis of what is now the XFMV data file, and we added the visualizations to that. And right from the beginning, Professor Hollnagel had this intention that there would be this type of track and playback option, or a step-by-step analysis of an instantiation, and that we could use the FMV graphics as a way to do that initially, but he always had the idea of this FRAM model interpreter right from the beginning of the software development. And then in 4 years' time, 2018, we had the next version of the FMV, version 1.0, and this desktop version was the one that included this manual track and playback option, where you could record and play back by clicking on functions and instantiations to light them up in an animation. But it really was just a manual workaround for what would eventually become the FMI. Then the following year, we came out with the next version of the FMV, the version 2.0, and this had extra functionality and some experimental functionality. But it was released as a paid option to help support the ongoing maintenance and development of the software. Then, in 2020, during lockdown, Professor Hollnagel released his first FMI program, the FMI Basic, and we, at the same time, also looked at incorporating that into the FMV version, and that was the version 2.1. So in that same version, we added some experimental functionality with metadata and equations as a test bed that could be used to try and develop other ways of visualizing analysis of a model. Then in 2021, we started developing the web-based version of the FMV as a way to future-proof the programming environment to replace the aging environment that was used up to that point. We needed something that was more flexible, that could run in different operating systems without the development overhead. So today, I'm very pleased to announce that we have the FMV FRAM Model Visualiser version 3.0 that has gone forward to public release. So we've confirmed that this development environment is a good one for us to use for future development, and we've included all of the FMI basic functionality within this version and other formatting features that were previously only in the paid pro version. But now this is all free and publicly available. And we've moved to a solid open source platform. So all of the source code is now published on GitHub, and that's available for anyone to look at and to even continue development building on top of that base. So it's actually possible to set up a development base for free using freely available software tools to start developing and extending further functionality on top of that FMI 3.0 Community Edition. So all of the resources that I'm talking about here are available on GitHub. There's a link here to the FMV Community Edition, and when you're on that site, there's links to the software itself as well as other documentation and resources. So if we go to the GitHub site, the first page that's displayed is the source code. There's the README with some basic information and links to more information. The wiki that's available here on the GitHub site is where you can find the instructions plus other documentation. also here we have the link to the software itself, the working application. So the latest version should always be available at this website. So if we go to that website, fmv.surprise.co.nz, the application opens. The first time that you access it from this website, it may take a little time for it to initially load as the application downloads support files to your browser cache, because that's how progressive web applications work. And ultimately, you should be able to run the application offline once it's set up on your computer. Now, the first thing I'm going to do here for demonstration purposes is to zoom in on the screen so it's a bit easier to see on the video. So I'm going to zoom into 150% here to make the commands a little larger. I did that by holding down Control and scrolling with the wheel. This is a browser command. There's also the zoom commands here under the browser menu. So at the moment we're at the 150%. First thing I'm going to do here is use the plus button to add a new function into the model. So there's our new function, and the cursor is now in the name text box, so I can type this is a new function. Of course, in reality you'd have a more meaningful name, but this is just to demonstrate. So now you can see the focus has moved down to our O button. So these are the aspects of the function. So I'm going to hit enter here to activate an output, and I'm going to type first output here, first output. And then if I tab away from this box or click on the empty space, it's going to enter that value. So if we go back to the plus button here, I'm going to press this again, which adds another function, and this time I'm going to name it second function, tab, here we go, and I'm going to go down to the input here. I could use my mouse to click on here, or I can tab. Or the other thing I can do is press I on the keyboard and it's going to jump to that button, enter, and I'm going to call this input. So that's also an orphan. Now, let's say that I defined this function with the same input as the output for this. So I'm just going to go back to this output, select and copy that text, go back to this input, and I'm going to update that to that same text. So now, because it's the same text, the model connects those two with a coupling. And we can select a function by clicking on it with the mouse, and then after a function is selected, we can then hold down the mouse button and we can drag that function around. And when we do that, the couplings adjust with that movement. Now that we have a basic model within our application, I'm now going to run along the buttons, the commands that we have along the top on the menu bar. So this first button is the upload. So we would use this if you have an existing model that you want to load and start working with, right? And by default, this is opening up a browser in the downloads folder. So this is where you can open an existing model and start working with it. Now in this case, we've just created a new model and we might want to save that. So the second button is the download or the save function. So if we click on that, by default, because we're in a web-based application, what it's done is saved a copy of that file into our local downloads folder. Now where that's located on your computer depends on your local computer and browser setup. Most setups by default have a downloads folder. Once it's downloaded, you can change the name, you can move it to any other location, and then you can load it back in at any time into the application. The next button here is to save an image. So if I click that, it's going to download into that same downloads folder, but this time it's an SVG file. So that's a scalable vector graphic. So if I click on that, it's opened it up in a browser window, and we can zoom up and down on this model. It's going to look exactly like it did in the application, but this version can be inserted into documents, onto web pages. It can be used for publications to represent a graphical version of your model. I'm just going to close that browser window there. Now, the other three functions that we have next are zoom out, zoom in, the minus and the plus, or the one in the middle here is the zoom to fill. So what that does is takes the model and zooms it to sort of fill how big the screen currently is. Now, over on the right hand side, we have four other buttons here. Now, the info one in the far right, that gives you, some basic instructions and links to more information. We have this one here, show labels. So what that does is turns on or off the coupling labels. Now, the next button is what we call render options. Now, the other button here is for logging in to the system. Now, if you press this, we have a sign in form that comes up. Now, the application is completely free, but we do ask for a sign in, a registration, to unlock additional features of the software. I'm going to sign in using an existing account. Right, so now my model's still available, but there's quite a number of additional buttons that have now become available. So it's this additional authenticated logged in functionality that I'll now cover off. So the first thing I'll point out are these two new buttons at the top. So we have an undo and a redo. Let's say we add a new function and we move it over here, but that's all wrong. So I hit the undo, that undid the move, another undo, that's the name being changed, and another undo was the creation of the function. Oh, no, I do want it after all. That's fine, we can do the redo steps. So there's kind of a limit of like 500 steps that it remembers. So it should be more than enough than what you need to either undo, redo any changes that you make to the model. Now, moving down the left hand side here, we can see some little buttons here pop up underneath the plus. So what this does is it allows you to adjust the text size within the functions. So we can decrease, you can see the result happening in the model, or we can increase. Now, after we decrease or increase, and we want to go back to the default, can't remember what it is, just hit escape, and that'll take you back to the default setting. Right down the bottom here, below all of the aspects, we have a similar button. Now, what this does is the same thing as you might imagine, but for the coupling labels. So here we see first output, second coupling, and so on. So pressing this, we can increase the size of that text, or we can decrease it. And again, hitting escape, take us back to the default. So it just allows you to fine-tune your model, especially if you're going to use it for insertion into documents or other publications. Now, we have another button here, function color, that's available. Now, that's not going to do anything unless we select a function first. So I'm going to select second function here. Now we can see our name, output, input, precondition, all available here for editing. And now if we press the color button, we get a palette and we can select a color. Now, if I click away or hit enter, it then applies that color. So the colors is just a way to differentiate between different functions, depending on how you might want to group them or present them for a specific model. Now, I just made a mistake. I didn't want the blue on here. I can undo that, or the other option is I can go back into color and choose the white or the reset button here, and that is going to remove the color from the function. The different render options that are available by using the render options button here. But now that we're logged in, there are 3 additional views that are also available to us. So I'm going to demonstrate those by loading a different model. And this is one that just shows all of the possibilities of different types of functions and views that are available. So here we have the traditional view. One click here, we go to the modern view, another click to the floating. And now if we click once more, this is a view that's inspired by the Assuring Autonomy International program at the University of York. Now, they produced some very excellent introductory videos of the FRAM modeling, which I highly recommend for you to check out. There's some links to those in our documentation. So in each of these renderings, all of the functionality is available the same in terms of interacting with the functions, but the colors and some of the shapes are dictated by that render options data. And one more click here, we go to a view that is based on the original icon used for FMV and for the FRAM software. One more click, and this is just a demonstration to show the diversity that's available in those options files, which now with the open source code you can modify for future projects if you have a specific color scheme that you'd like to use for your project. But just to remember that FRAM functions are always hexagons and they always have 6 aspects. So now I'm going to move down to the bottom left hand corner and explain this group of buttons down here, which is the FMI, or the FRAM Model Interpreter. And to demonstrate that, I'm going to open another model. So I'll go to my Open button, and there's one here, Leave Harbor Example. So this is an example that is used in the instruction manual. I'll hit the zoom to fill just so that we get it centered nicely on the screen. Now, you don't have to do this the first time that you use the FMI, but it's a good habit to get into to reset the model before you start stepping through it. So this is the first button here, which just resets, ready to do an interpretation. Now this next button is the advanced one cycle, or the stepping function. So I'm going to press this button once, and the FMI, or the FRAM Model Interpreter, has now initiated. And the first thing it's done is it's highlighted our background functions, and so these were the ones that have the grey background. If we remember that the foreground functions are the ones that have the white background. So it's highlighted these background functions in 3 different colors, because these are different types of background function based on the FMI rules. So the green one here, the finish loadings, this is green because it's identified as an entry function. So that means it has only outputs, and that at least one of those outputs goes to an input of a foreground function. So this initiates or begins or starts an interpretation of the model. At the other side here, we have one that's highlighted red. So this background function has only inputs, which means it's a sync or an exit function. So that will fire at the end and defines one of the outside boundaries or the finish boundaries of the model. The third background function that's highlighted blue is a background function that's not an entry or an exit, because it only has outputs and they only go to other aspects of functions, not inputs specifically, which means that they are not in themselves variable, but their outputs are always available to downstream functions as aspects when they're needed. So this is cycle 0, where the entry has been identified and the outputs are now highlighted green as well, which means they are available to downstream functions. So you can see that we have an input going to this trim vessel function, and we also have an output from finish loading going to an input of man harbour stations. So that means that those inputs are available to those functions. And the third one here is a precondition. So after cycle 0, if I now advance one cycle, we go to cycle 1, we can see that man harbour stations and trim vessel have activated. Now, the chain in place, which was a precondition on closed bow doors, is still present on the next cycle because it hasn't been used, as it were, by this function. So these 2 functions have produced their outputs, including a precondition that goes to closed bow doors. So now all of the aspects are present on closed bow doors, so I would expect that to activate on the next cycle. along with drop moorings. So let's advance one cycle. Here we go. Close bow doors is activated and produced its outputs, so has drop moorings, and now everything is available for to leave harbour. On the next cycle, to leave harbour activates, produces its output, and then finally we have the exit function start sea passage activating. And that's the end of the interpretation. Now if I reset this and use this next button, it's going to step through that from start to finish in one go. So let's continue the interpretation. So there it is, highlighting and animating the activation of the model, or the demonstration of a specific instantiation of the model. Now if I reset and start again, you notice that this button changes to a square, a stop button. So you can stop and replay at any time during that playback. The other option we have at the bottom here is a delay between the animation of that instantiation playback. So we can adjust that. If I go to reset, and I'll move this back a couple of positions on the slider, and now continue the interpretation, you can see that runs through a lot faster. So you can do it faster, you can do it slower, just depending on how you want to observe the model progressing. And if we take it all the way back to 0, it's just going to fly through from start to end, which for other purposes later on might be useful for very large models. And the final button on the interpretation here is the show FMI log. So once we've done an interpretation, we can press this button and it's going to give us an output explaining what happened on each of the cycles. So the identification of the entry and exit functions, the profiles of them, and then whether they were activated on each cycle or not. And you can also use this button to produce that as a text file that you can save. What I've demonstrated here is a complete working model that works in an interpretation from start to finish. But it may be the case that your model doesn't work the first time. And the first thing that the FMI does when it interprets a model is it looks for some common errors that would prevent it from functioning properly. So I'm going to show you the example of what happens when there's an error present. So I'm going to upload another version. It's our render options that we used before, which is just for a visual test, and it's not actually a complete model. So let's run the interpreter on that and see what happens. So we go to the first advance one cycle, and the log comes up straight away and tells us that we have errors. So the problem is that this function, number 3, has an orphan. So you cannot interpret a model if you have orphaned aspects that do not make couplings with other functions. So that's one of the basic rules of of completing a model and running the interpreter, because you need everything connected to at least a background function to define the outer limits and the boundaries of the scope of the model. So now I'm going to modify this function to, instead of fixing the orphans and adding more functions, I'm just going to delete these aspects. So if I go into the text and delete it, you can see that the whole aspect is gone. So now function 3 does not have any orphans. I'm going to reset the interpretation and step through the first cycle. We still have a problem with that function. So the problem here is that it does not have any inputs and it does not have any outputs. So because it has a precondition, it has an aspect that's not an input or an output, that makes it a foreground function. And foreground functions, like the one that we have over here, have to have an input and an output. So I'm going to take this coupling here. It should demonstrate at least that we can get the interpretation working. So I'm going to add another output. So now let's reset the interpretation and start. Now this function is a true foreground function. It meets the rules of the FMI interpreter, and we've identified our entry function, our exit function, and our other background function. So I'm going to jump now to a different model to show the final functionality that we have available to us for the FRAM model interpreter. So if I open this model, I'm also going to go back to a normal zoom level. So this model, if I reset the FMI and I advance one cycle, it has identified the entry and exit functions. The external events coupling output here is now available to the downstream functions, which could activate on the next cycle. So I advance one cycle and nothing happens. Press it again, nothing happens. Now if I look at the FMI log here, it's going to tell me that on those cycles, no functions were activated during this cycle. Why? Right, let's reset, and I'm going to look at this second function here, to monitor. Now what happens by default in the FMI is a function will only activate when it receives an input, and by default it has to receive all of its available inputs before it will activate. And by default it also has to have present all of its other aspects. So this function to monitor has a time aspect, monitoring schedule. Now the problem here is that monitoring schedule comes from a function that doesn't produce that output until downstream from to monitor. So to monitor has to produce an output on a situation which will activate to learn, which will produce an output, monitoring schedule. So this type of problem with the FMI is common where you have these types of feedback loops. For us to test the model in the FMI, we have to bypass some of these conditions. So let's click on this function to monitor, and where we enter the aspects in the pane down the left hand side, there are some hidden buttons underneath the aspect buttons. So if we go to the time aspect, monitoring schedule, I can click this button and change the profile. This is the FMI profile for that specific function. So by default, it needs to have all of the time aspects present before it will produce an output, but we can click this button and change from all to any, or any means that it could have any one of, if there's more than one, but it still needs at least one. So in this case, we need to set it to none, so that the output would be produced when this specific monitoring schedule time aspect is not present. So now that that's set to none, I'm going to reset the model. There's cycle 0, entry and exit functions. Cycle 1, yes, to monitor, fired, without the monitoring schedule being present. Next step, to have a planned response. Next step, nothing. So what's happened this time is that to provide the resources needed has a control aspect, which also is not present yet, because to learn hasn't fired, because the action command hasn't arrived as a resource for this one to fire. So to progress any further, we have to modify either to learn or to provide the resources needed. I'm going to modify to learn. So let's modify this resource. Set that to none. So now to learn can produce outputs without the action command being available as a resource, at least for the first time. So let's reset 0, 1, 2, 3. So to learn fired, to anticipated fired. So now all of the aspects on to respond are available. Now we have the output available to learn and to act as fired. And that's the end of the interpretation. Exit function has been activated, and after that no more functions were activated. So without going into details about why and how you would model this specifically, I'll just show you the final command that's available to us. So to learn is now has the resource present, and it's produced an output for monitoring schedule. So it's possible for these functions to fire with more complete aspects present, but that doesn't happen because the entry function to cause an event only fires on cycle 0. So the final option that we have, if we click on our entry function, is there's a text box underneath the output button here, and we can put in a number, which means that this function will produce its outputs and initiate the interpretation. Not just initially, but we can set it to be on a specific number of cycles. So let's put a number 5 in here. I'm going to reset this, and I'm going to play it this time. So here we have cycle 0, 1, 2, 3, 4, 5. Right, so now we're up to cycle 5. I just pause the play. I'm going to move one more cycle. So now to act, our exit function has activated, and because this is cycle 5, our entry function has activated again, which has kicked off another round of interpretations. And again on cycle 10, so this is every factor of 5, it's going to activate that entry function. So we can continue the interpretation, and it's going to cycle over and over, because we have that entry cycling in the same cadence as the number of cycles that it takes for the model to go from start to finish. By using these options, you should be able to at least show that the model is syntactically correct according to the FMI interpreter, that a model was capable of cycling through all of the functions and making potential couplings from start to finish. Up here we have what's called a table view. So I'm going to reset this model and open the table view, and it immediately goes into a split screen. So we have the model on the right hand side, which I can resize if I wish, and on the left hand side we have a table that shows the list of the functions. Now if I select a function in the model on the right hand side, you can see it highlighted in the table. Alternatively, I can click on either the number of the function or the title, and that will select it in the table, and I can also see it selected in the visualizer on the right. Now by default we have the ID number for the functions. This is the order that the functions were created, and that's sorted in ascending order, but I can click on that title and reorder that, and that happens with any heading within the table. So I can sort by the ID name, function type, color, and so on. Now these orange columns here are the properties of the functions that are available to us. I can turn that on or off. The other groups that are available are the aspects. So this function to learn, right, has 2 aspects, right? Lessons learned and monitoring schedule, and we can see those as outputs coming from the function in the model, and it has 1 input and it has 1 resource aspect. The other thing that's available to us here is the FMI profile. So that's where we made the changes earlier to say that the resource did not need to be present for this function to learn to produce an output, and similarly for the to monitor, right? So they're the 2 functions that we modified the FMI profile. Now for whatever columns are available or visible here, we can then save that as a CSV file, which can be opened in Excel. And then go back to a basic view of the functions. When we run the FMI, if I reset it and then advance one cycle, cycle 0, whatever is highlighted in the model, like in this case the entry and the exit functions, we have the same highlighting within the table. So it's just another way of visualizing the interpretation of the model as it progresses. And similarly, if I change this function, one of the ones that I modified, right, I'm going to go back and change this to all profile and rerun the model. So in this case, the model is not going to progress all the way to the end because it gets stuck, right, on this to learn function. So let's stop that interpretation, and then I can see which functions were activated and which functions were not activated. So it just helps us identify whereabouts in the model that the progression was held up because of those profile conditions. Right, so I'll reset the model. Now, if we click on the table view a second time, we go to a full screen view of the table, and click it again, we go back to the visualizer view. Next to the spreadsheet button, we have another button called Reload. And what this button does is, if you have to refresh the browser or close it, or the computer resets for whatever reason, pressing this button should reload the last version of the model that was being worked on. So whatever was last within the application, you should be able to restore it and reload it using this button. And finally, we have the logout button, which will take you back to the most basic functionality that we began with at the beginning of the demonstration. That's all of the functionality that's available to us in the new 3.0 version of the FRAM Model Visualiser.